Okay, well, good afternoon, everyone. So welcome to the next episode in the EMMC webinar series dedicated to explaining the developments of the VIMP, future VIMP and MarketPlace on materials modeling applications. So today it will be our pleasure to have several guest speakers from SINTEF in Norway and from STFC in the UK. They will be talking on the following topic, which is ontologies, data management, and interoperability for digital marketplaces. So I will now make Sylvia Kakra from STFC as the first speaker, and I will just have to make you host in order to allow you to present.
Thank you. So I should be able to share my screen.
Yeah, now you should be ready, yeah.
Yes. Can you see my screen?
Yes, we can.
Can you? Okay. So good afternoon, everybody. So this will be a joint presentation. Should I? Wait, let me just remove this. Between UKRI, STFC, and SINTEF. So it will be a choral one between Martin and myself from UKRI and colleagues from SINTEF. So this is the plan of the discussion and presentation. So we have first a presentation by us, short discussion, a presentation by SINTEF, and then there would be a moment for discussion of synergy ideas. Should I go to presentation mode? So Martin, Orschen, and myself, we are from STFC Dasbury Laboratory, UK Research and Innovation, and this work was done in collaboration with Michael Seaton and Ilan Todorov. The VIMP and MarketPlace are two ongoing Horizon 2020 projects, which are sibling projects developing digital marketplaces, which will be platforms to connect users and providers in the area of materials modeling. So typical providers, you can see, would be software owners or modeling experts, and typical services that will be traded on the marketplace would be, for example, training services or translation in the EMMC sense, so from an industrial problem to a modeling solution. And this platform will be open, and its interoperability relies on semantic standards, namely a set of ontologies. So when it comes to standardization, there are many different standards we can think of that can be intended for humans or for machines, and they can be at different levels, so syntactic, semantic, or pragmatic level, for example. So there is a wide spectrum that goes from unstructured vocabularies up to ontologies. So you have in this cartoon, I'm showing that we can agree on a set of concepts, but just have them as a list or give a structure to it. Now, while everybody agrees that having standards is valuable towards interoperability, there is no common agreement on whether we should go for lighter, less expressive languages, which have a limited expressivity, but on the other side are easier to handle with multiple tools, or to go for richer languages, which allow to describe complex relations, but on the other side are heavier and rely on less widespread technology. So it is a design choice to be made, and sometimes one chooses to go for a compromise between the two. So our work connects to some assets that have been developed within the community, and in particular, MODA, which is a template to describe simulation workflows, ROM, which is the review of materials modeling, which is a book, and in particular, it includes a classification of models according to their granularity, and the EMMO, which is the European Materials and Modeling Ontology, which is a top-level ontology for applied sciences. So these three assets, as you can see, they sit in different places within the spectrum. So what are ontologies, since we are talking about them? So in philosophy, ontology is the science of what is, whereas in information science, an ontology is a formal machine-readable representation of knowledge in a domain. So it identifies the categories that exist and the relations between them. They are useful because they allow automatic reasoning and an easier exchange of information between different sources. And to put this in the bigger context, I should mention this sits in the context of semantic technologies, and in particular, I would like to recall the semantic web concept, which is an evolution of the World Wide Web, was already proposed in the 90s, and the idea is to have, instead of ad hoc links between web pages, as it is in the www, it is based on semantic links between the pages. So within the VIMMP project, we have developed a system of 8 ontologies, which you see here, represented where each ellipse contains an ontology, and the arrows between them indicate that concepts from one refer to concepts from the other. In particular, I would point out, I don't know if you can see my mouse, probably not. I would point out OSMO, which is the ontology version of MODA, and OTRAS, an ontology for training and topics. Anyway, they cover all the aspects of the marketplace, all the concepts we expect to appear in the marketplace. How do we use them? We will use them in data ingest, and then for search and browsing, and they will be the base of internal operability of the various components. Concerning users and providers, so users will see them indirectly via the keywords when they search for goods, for example, and the results. And they will not be frozen, so there will be a policy to allow to request for extensions. And when it comes to providers, they can choose down to which level to adhere to this common language. And the deeper the adherence, the deeper, of course, the interoperability with other services. There was a release in July, and you can find at this address the ontologies together with the documentation and with the example scenarios. And the following ones will also be available on the Fraunhofer GitLab given at this address. So now I will pass over to Martin to give examples of no. So how should I do this? Wait, sorry. Martin, are you the host?
No, I'm not.
So I'm assigning in principle and
actually, Sylvia, I can do
it. Yeah, sorry.
So as Sylvia said, one of the purposes of the ontologies that we develop for VIMP is to use them at the back end for data management purposes and to govern data ingest and data extraction. Our backend component is Ontologies. It's developed by project partner Osthues, and there will be a dedicated webinar to present Ontologies and particularly the API by which others can connect to VIMP and write and read data using that particular API. In addition to this, there will of course be a web front end that everybody can access without any specialized technology. Now, this connects to what was presented in the general webinar on the marketplaces as one of the components of our domain ontologies is a taxonomy for topics that exists in materials modeling. This is used for many purposes, to find and annotate training materials and events, models themselves, services, but particularly for our translation router, a demonstrator app that was already developed and presented, and by which matchmaking is facilitated. When an end user comes and describes a scenario and his requirements, you have seen in the last presentation that there is a visual platform, the translation router app, where successively the end user is presented with a series of questions. For example, what kind of model are you interested in? And there are associated topics corresponding to those models that are mapped to the classification of materials models, closely related to ROM, which you see here at the 4 levels that we have from electronic to continuum. Then the type of material, the area of business, and the translator information is also annotated by the same topic codes. And the same goes for many other types of information that we have on the platform. And this facilitates accessing the information and extracting it. Then one particular aspect that is relevant for any kind of digital infrastructure that deals with data from materials modeling is the characterization of the data provenance. So how have the data been generated? Without such information, as we all know from practice, data are basically useless. You can find data in a paper, in the extreme case, only in a graph. To make a real use, reuse the data and make them interoperable. For this purpose, a description needs to be provided how the data point was obtained. This is why the EMMC community has put such an effort into developing the MODA standard that is for annotating precisely data provenance. Otherwise, the only thing that you can do is ask the person in charge of generating the result, which may have been long ago, and it may well be the case that all the information on the data provenance has been lost. The person doesn't remember. You would have to conduct almost an archaeological exercise to retrieve this. And this is what we all want to overcome. This is why we do digitalization in materials modeling. It is to make all research data in materials modeling fair by adhering to the fair principles of data stewardship. And for this purpose, as the basis of this, we rely on what has already been developed, which is MODA. And this audience is familiar with MODA. You have those 4 paper sheets in the MODA form, which we call sections: the use case, the model, the solver, and the processor, and an overview sheet. And in there, you have entries that we call aspects. For example, the time step, the boundary conditions, and so on and so on. In this form, this is text-only information. And here we would like to go beyond this and make use of the feature of the semantic web, that you can actually link to anything that exists elsewhere on the semantic web, and for this purpose upgrade this to an ontology. Another aspect that where we have had a detailed look at MODA and how this was made use of in ROM are the blue arrows between the sections. They all look the same, but their meaning is not always the same. And also the way they have been used in ROM was not 100% consistent. Some people gave a certain interpretation to the blue arrows, some gave another. So when we were characterizing the semantics of this, we thought it would deserve an effort to be made more precise. So this is why we turned MODA into an ontology. This ontology is called OSMO, the Ontology for Simulation Modeling and Optimization. And here you see the graphical representation of this ontology, which is again based on the graphical representation of MODA. What you see here is first of all the sections. They are the same. They have the same colors, the use case, the model, the solver, the processor. Instead of the blue arrows, we have dedicated elements called logical resources, where you can describe what sort of information is exchanged and in what way. And there's also certain kind of information on iterations and so when there are multiple instances of a certain sub-workflow. Good. This being said, a MODA description is one-to-one already an OSMO description. So this is the ontology version of MODA. If you have something that is described in MODA, it is also by definition already described in OSMO. And if you go in there and provide the details of a section, so the aspects that we talked of before, for example, the time step, then this is based on the exact representations that we have seen before. And because this has become an ontology, these entries have their own concepts and are related to the section by the corresponding relations. Instead of text-only information, you can also provide object information. So point to some entity present on the semantic web. In this way, we have gone from a semi-formalized standard to a formal ontology, from MODA to OSMO. The same approach is what we are taking with respect to the other standards that have been developed by the EMMC community. In particular, concerning how best practices should look in translation and what services we as a community can provide to industrial end users to make them exploit academic results in materials modeling at the state of the art, which there is a major gap in, and our activities as a community aim at closing this gap. So there we have the EMMC translation case template. You describe a translation case, and there is the EMMC translator's guide. And we have also collaborated in this respect with the FORCE project, where there were some internal standards to describe the different stages that you have in the translation process as it is characterized by the EMMC translator's guide. And as we did with MODA, we simply provided an ontology version of these standards, and this is called MMTO, the Materials Modeling Translation Ontology, an ontology for translation. This is one of our domain ontologies, and similarly, you have aspects to describe the translation case, the industrial case, and the business case as defined in those documents, in the same way as you have for the four aspects from MODA, for the four sections from MODA. They have aspects, and they are simply those lists that correspond to the entries, or in this case to the stages from those EMMC documents. Good, and evidently the core of the business concept and the whole concept of the VIMMP marketplace revolves around the concept of translation. Why do we bring a benefit to community? Because we aim at having an excellent community of translators that provide additional value that is absent if you don't access the marketplace. So for that reason, the concept of translation is absolutely at the core of this. So this is one of the reasons why we focused on this particular topic. Then I'm not going to describe the other ontologies in detail because this would take too long. However, just an example. This would be a knowledge graph. So here you have entities. The entities are annotated by their concepts. They have relations to each other. And this is to describe a molecular model. This is one part of the knowledge graph where you see that use is made of MODA, or in this case OSMO. Then here you have the part where the actual model parameters are characterized, in this case for a model for acetylene. We paid attention that the way we describe this is compatible with the way in which models are described on the MolModDB database, which you find here, where there are a lot of molecular models for fluids. And by such knowledge graphs, when you transform them into a tree, you can easily produce a JSON-LD representation, which is a beneficial form for exchanging annotated data if you don't want to export an entire ontology, but only data and metadata. Then JSON-LD is a good format, and this can be obtained in this way. Now, short remarks on another thing that was of great importance to us as a project, which was from the very beginning, long before the EMMO has been released. Right now, the version 1.0 release of the EMMO is not available yet, but it's close to being available. And as these developments progress, we follow them very closely and paid attention that all our ontologies are aligned with those pre-release versions. And now it's O100 beta. Via the EVMPO, a top layer of our domain ontology, is the European Virtual Marketplace ontology. The concepts are taxonomically aligned with the EMMO. Then beyond the taxonomy, the EMMO has two main kinds of relations, which are either on the one hand based on semiotics, following the approach by Charles Sanders Peirce, where you have a representation relation, represents or is signed for, here we abbreviate it by S. Something is a sign for something, abbreviated S. The other main kind of relation comes from mereology, which is integrated in merotopology, as you may have heard from presentations by our colleagues. And here we use P to represent the relation is proper part of in 4D space-time, which is what all kinds of entities are in the EMMO. So we have parthood, we have representation, and we have also our taxonomy aligned with the EMMO. To align the relations with the EMMO relations is not always straightforward. This requires, say, some effort at organizing this properly, because our relations are often more complex than those of the EMMO, in the sense that it's not a one-to-one mapping, but one of our domain ontology relations has to be mapped to a sequence of relations. So parthood and representation need to be combined, and the knowledge graph needs to be unfolded, the structure needs to change so that proper alignment is done. These are techniques that are well known from ontology alignment, and we have implemented them here. Additionally, we found, and here I would be interested to hear the opinion also from our colleagues who are involved in these efforts, we found that some of our relations are not properly representation of parthood, they are modal in nature. So they are expressed as necessity or possibility, particularly when you deal with requirements. For example, a software requires another software. This means this software needs to be present so that the other can be present. This is modal. And we gave an attempt, a first attempt at sketching how this could look. And there it would be of interest to have some discussions as to how this can be aligned with the EMMO or can be made somehow coherent with the EMMO. And with this, I guess we have a few minutes for discussion, or we don't, because we're already over time. Apologies for this, but let's give a few minutes for discussion nonetheless. We also started a few minutes later.
Is Gabriel there? Yeah.
Yes.
Yes. Okay. No, just because you are hosting, maybe to ask if the colleagues would like to make some questions. Some comments.
Sure. Yeah. So, are there any questions at this stage?
Basically, if I might, Michael, Martin and Sylvia and Martin, thanks a lot for the presentations. So the question might be, we have somehow a challenge of, say, rather something like mapping and alignment, and we have got connections to some semi-formalized standards. So one might assume that semi-formalized standards change with the time. So would this mean that the ontologies and the relations in the ontologies would also have to change by time? Or is there a link which automatically updates these ontologies if the standards change?
I see it the other way around. It is not so probable that there will be major changes to MODA, or we don't know it. These are documents, for example, MODA is already has a CEN workshop agreement. So we don't know how much of this will change. And also the EMMC translators guide, how much of it will change. This is semi-formal, but it's quite stable. But the domain ontologies, they will indeed have to change a lot. think about the topic taxonomy. When the platform is in use, when it's running, I guess that quite often we will detect topics that we have not had on our list. So it is absolutely essential that the ontologies can change and that they can be extended and that there is a way to re-annotate data when the ontologies change. That's absolutely essential.
And that means that it's very important to have proper versioning of the ontologies.
Yes. Yes, but should I make you the host?
I think Teresa, she would start the presentation and then I will take over.
Yeah, yes,
Good.
I can.
So
Yeah.
it would be nice.
Can you see my screen?
Yeah, we see it.
Cool.
Maybe
Okay.
you can turn on your camera.
Okay, I'm not getting that option. Okay, I'll just continue. Okay, cool. So good afternoon. Welcome to the Marketplace demo about running an application on Marketplace. So different types of applications with different functionalities can be registered within Marketplace. And this can be combined into a workflow. So these different types of applications can be like simulators, web apps, databases, post-processors, transformation applications, and so on. And owners of these applications are in control of who has access to these applications, where and when to run, and how it is offered to the Marketplace. So as you can see, the Marketplace API is what controls or gives access to the application. The user can access it only through the application API in Marketplace. So Marketplace has a lot of capabilities. That is, the capabilities are tags which match Marketplace interfaces with application endpoints. And this helps build workflows because these capabilities actually represent the functionalities of an application. And to implement this mapping, we use application ontology. So for example, if the application is of type data source, it has get data set endpoint, and through that, and if we have the application ID of the app that is registered on Marketplace, we can access it through this get dataset endpoint. And for example, if it's a transformation type of application, then we can create a new simulation, run a simulation, stop a simulation, and so on. So this flow shows the interaction of two applications via Marketplace. That is, we have one application which is, sorry for the typo, it's actually a data sync and data transformation application, and we have a data source application. So this application can run a simulation and store an input. So what the user does is he calls an endpoint, which is like this, to create an instance of the simulation. That is, he calls his ID. The application ID is that of registered with the Marketplace. And Marketplace places an internal call to this application, and which in turn creates a response. A response will be a job ID. And the second one is then he needs to give the data for the simulation to run. And that is, has the application ID and the job ID that the first API returned, and create dataset endpoint. So this actually acts as a data sync, and it actually gets the dataset, and it calls, Marketplace places a call for this application to the application A to get the data set, and it gives back the data, and the data is returned from the Marketplace to application B, and which stores the data in application B and sends back the response. And to run the simulation, an internal call again goes to application B, and the simulation is run. This is using this statement. And I would like to show a small demo which shows the interaction of data sync application and a transformation application. Okay, so this is a pre-recorded video because of time constraints. This is what we are going to show. Okay, is it visible?
Yes.
Okay.
Can you turn on the sound?
Yes. Its sound is not sharing.
Maybe you can just speak next to the video.
I didn't get you. What?
Maybe you can just tell what you're doing in the video.
Okay, of course.
It's
I can do
difficult.
that. Yeah, that's easier, I think. Yeah. So this is the Simase app with MarketPlace. So we have as there are preconditions like the Simase app should be already registered in the marketplace, and also the user should have input ready. So this is actually the ID of the marketplace, and it's approved by the marketplace. So this is registered, and now we have like 3 steps to execute. The first step is to create an instance of the new simulation, and the second is to provide input, and the third is to run the simulation. And these are the APIs that is used to like create a new simulation. Then we get a job ID as response and provide input, and we give cuts payload for that, and we have run simulation to run the simulation. So the first one, we actually, it's a post call and with the new simulation endpoint, and we get the job ID. And in the second one, we actually call this to provide the input. I already have the cuts payload in the body of the call. So that actually stores the data, cuts data in the database of the Simase app. So, and the next one is to run the simulation. And once it's run, the process is started, and after a while, we will get the output of the transformed cuts. Thank you.
Thank you very much. I will continue with some more details. It's really a nice video, Teresa. Could you make me a presenter?
Okay, you should be host now, Jasper.
Good. And you see the screen?
Yes, we can.
Good. So just continue. So what? So we'll just show, go into the detail what is actually happening behind the scene, where in this app that Teresa demonstrated. So first, it's built on the ontology. It's based on EMMO, but we also use 2 domain ontologies, the crystallography and the atomistic, that are important. And then in addition, we have an application ontology for this app. Yeah. That just add a small layer between between cuts and the EMMO-based ontologies. And then COTS provide just a command that in order that allows us to generate now a COTS representation of the ontologies. So that is a metadata, and it allows now us to instantiate COTS objects that are instances or individuals in the ontologies of the ontologies. So maybe let's see if we can move this one. So what we are trying here to do, the actual simulation case is to calculate the energy of an unit cell of aluminium. So you have a unit cell here. It has the unit cell parameters 3 vector A, B, and C. In addition, it has 4 sites in a facet FCC lattice. So if you now go into the ontology, this comes from the crystallographic. We have a crystal structure which has a unit cell, and the unit cell has 3 lattice vector, and then we create individuals of that, A, B, and C, and these are created in the application as COTS objects. In addition, the ontology, it has a crystal structure has a set of sites that are creating individuals. Actually, the application do not do this, but formally it does should do this. So they create 4 instances of sites, and these sites has a spatial direct path, for instance, a position, and they have the name of the species, they correspond to the atomic number, and so on. These are Wyckoff symbol occupancy are in the ontology, but not really implemented in this application. And again, position of an atom is actually 3 numbers. So that is also has also to be instantiated. So a lot of instances are actually created when starting this application, and these instances here will then be converted by the patient to an ASC object for the application actually to run. What I want to show you, because that is a very new development in EMMO, is ordering. And it is, so we have defined 2 relations, a has first element and a has next. So for instance, we can go here and say that the individual corresponds to a crystal structure. Has direct paths, some sites, and these are then, it has a first element that points to the first site, and then it's simply, you can walk through them by, has next to that, that way you get ordering. So this is very similar to how it's done in RDF. Yeah. So the next step was Teresa showed was fetching the data from the source. So really what the user does is that tell that I want to use aluminium, or want aluminium unit cell as input. Send this information to SIMmaster that communicates with the ontology via score. And essentially what it does is that it looks up into a database for CIF files and find a CIF file for aluminium, and returns that. And the output from the application is a COTS instance of this unit cell aluminium. And that can then be used in the next step, where the user wants to calculate. Essentially, this is, okay, it's not formalized like that, but essentially what the user says, essentially calculation parameter. For instance, if you want to use the very simple EMMC calculator that is built into ASE, and the application is then speaking to ASE as an engine that are performing the calculation, and output simply comes, for instance, a potential energy as a number. What should have been done in the next step is, of course, that this results here should be represented in terms of the ontology. Yeah, that is our very short demo. I think we are trying to keep up with the time, but thank you very much.
Right, thank you. Thank you, Jesper. I don't know if the participants have any questions for SINTEF at this stage. If you do, please feel free to ask your questions and remember to unmute yourself first.
This is Theo from IRES. Hello, Jesper. Thanks a lot for the nice presentation. I was wondering, how versatile can the input of the user be for the simulation? In the demonstration video, we saw an ontology provided by the user in the form of an ontology. Can you accept other formats? How can you handle different formats of input to run the simulations? I was wondering, how flexible is the system?
I think it's we should really have what Thomas here, but it is very flexible. The applications, they need a reader. So somehow we need to some application that is able to read your data that you provide as input, convert it into a COTS payload. But with that in hand, so if you're able to register a converter, then it's very flexible. I think that is the right answer.
Okay, thank you.
So the functionality needs simply to be implemented in the marketplace, but it has the flexibility to allow it.
I can maybe comment on this, that we are working on this, integrating Optimate into this as exactly this service into the marketplace, ontologically as well as a data source. I have an example for this.
Yeah, I'm just asking because, of course, you know that it's the most important to offer those semantic technologies to people that don't deal with ontologies normally. They can just have the benefits without the effort.
Jesper, this is Borek Pacak from CTU. I have maybe a follow-up question. You mentioned that you need some sort of a reader that transforms data into COTS payload that are then basically passed to the application. How much are you dependent on this COTS payload format? And are you open to other types of payloads?
As far as I know, it's currently discussed, but marketplace, do you know more about that, Kasper? Whether COTS is the only standard we are supporting now, or do we?
Yeah, sorry, I should have introduced myself before instead of just injecting Kasper from EPFL. So concerning using COTS, I think that is at the moment still the choice of format for the marketplace. But essentially, it's just a way of expressing the ontologies and using them technically right in actual implementations. So one could think of using other formats, but I think for the marketplace that is currently not intention, but as far as I know. But in theory, anything could be used, right?
Yes.
Yes.
I would guess it's a, I would not call it like a limitation, but it's a set of sort of like a prerequisite that you require, you know, in the process, and which is not completely ontological. I mean, it's some sort of specific format that you plug inside, right? And if you would open, let's say, marketplaces to accept other types of payloads, maybe application dependent, that would make it a more flexible structure.
Yeah, it's possible to, I think, hide things within, so you don't fully ontologize. The payload, just hide it as a binary block within a COTS payload.
Yes.
So if you want to transfer some data that is not doesn't make sense to ontologize because it's very, very specific or difficult to describe fully semantically.
Okay, thank you.
Should we go over to the synergy discussion?
I think that would be very interesting. So these ontologies you have presented, Thomas, no, sorry, Martin, they are they available now, all of them, using the LGPL?
Yes, they are. There was a first release, and toward the end of the year, before the end of the year, there will be a first revision of this first release. And any developers anyway can get a development version that's by asking us, so this will not be a problem. But the release is very close to our development version.
And the Osmo, that was actually developed together with George from the MarketPlace, because they are not really being used, as far as I know, within MarketPlace, but they should. That was the original intention.
Yeah, as I said, I mean, Osmo is very close. It's essentially Moda.
Yeah.
So if you have something in Moda, it's already in Osmo. How is it? Do you have some slides about for the synergies, or?
Unfortunately, I have not prepared the slides for it.
Maybe we could hand over to Sylvia.
Yes, if you can make me present it, I just.
So now you should be host, Sylvia.
Thank you, thanks. Last time when I tried to hand in, I was also kicked out. Let me see. So here now, so we will just have brief discussion about possible synergies. So the idea is, how can we combine our efforts of the two marketplaces so that users can, for example, query both simultaneously. So we have seen examples of simulations, but imagine that on the marketplace there will be other data stored, like, for example, profiles of translators and so on. So there are, again, various aspects. One is the business aspect, which is not the focus of this talk, which would be how do the users register to both marketplaces. There is the technical level, like how can users look for things in the marketplace. So on the VIMP side, there will be a GUI for manual upload and search, and it will be also accessible via REST API. And from what I see, it's, I think, also the marketplace, which is, I mean, it's a common approach for web services, and data and metadata are exchanged in JSON. So, but this tells us how, but the concept, the other level is what can users look for. And this, of course, depends on the details on the database. So what is stored and what properties are given and visible to the API. So focusing on this third content level, some possibilities we see to integrate our work would be to build on the EVMPO, what Martin already presented, the European Virtual Marketplace ontology idea. So to have some shared concepts on the top for the marketplace, so that we can agree, for example, to store data for this and to make some properties visible in the API for those. For example, to say each translator profile will include its topic of expertise, just to give an example. Otherwise, an alternative approach to an agreement would be to provide a sort of mediation schema, so a third schema, third ontology or asset, which maps to the two we want to integrate. So this is a typical approach when you want to integrate legacy work. And if we want to broaden the discussion also to other users and providers, to include them in the discussion, we can think, for example, of prospective users like the open simulation platform providers, and ask them to identify prototypical queries they would do, and this could help us to design the databases. So imagine Martin showed the example of the translation router. So there, the typical query would be to look for translators and their expertise, but you can imagine other tools that also need to perform queries on the database. So this would be some ideas we can discuss, and a bit of advertisement. So would like to mention a school in March 2021, which is a SICAM school supported by VIMMP, organized mainly by Martin, which is SWIM, Simulation Workflows in Materials Modeling, and hopefully will happen in Lausanne in March next year. And then I would like to advertise the next webinar, which will be on the 9th of December. It's the VIMP multi-scale modeling workflow for the simulation of food emulsions, and it's a collaboration between Polytechnic of Torino and Unilever, and will be given by our colleagues in a couple of weeks. So with this, I would like to thank you for your attention and let space for discussion.
Could we go back to the nice question you had in the beginning of this?
Sorry, Jesper.
The first slide you showed here for the discussion was very nice.
Yes. Let me go back. Yeah. This one, Jesper?
Exactly.
Yes, I think, yeah, we should consider the different aspects. Yeah, please go ahead.
So I see that there are many participants in both marketplace projects now. But the question here is, I think it could be very useful for users to be able to use resources available at these two marketplaces in one workflow. So this would kind of both require that the marketplaces can speak together, and that you have a common sign-on system.
Yes.
Yes, this will also be reflected in the upcoming EU projects, where this will be the focus, right, of transferring data and handling this.
Yeah.
Yeah, this will also relate to the question of the business models of the two marketplaces, to what extent data can be shared. It would be desirable that this can be done.
But I think that very much depends on the rights of the individual user. If the user has access to data at the two marketplaces, then the technology should not provide him for combine them. And what do we need to allow that? So of course, we a common ontological description, but also some support in the APIs.
Yeah, that's not trivial.
No.
In principle, what you need is this correct? You would need a third API that calls both, that invokes both.
Yeah.
Yeah.
We are so lucky we have the coordinators of the two marketplace projects in the meeting. Is that something that would be of interest to perform within the projects, or is it a topic for other projects like DOME, Open Model, or?
Hi, here's Welke. Can you hear me? You hear me?
Yes.
Yes, okay. Yeah. Just to say that in the other project, React Pro, maybe Sergio is here, Joanna here as well. We are exactly in the moment that we need to start this work. Then probably as a result of the React Pro, we are going to have this common access somehow via client. I'm not sure yet, but there would be.
So that's already something, a deliverable.
Yes, it's a deliverable that we just delayed actually for the React Pro project, but that we have to face in latest to deliver in the next 6 months, more or less. And that's what we started to work on, to understand from VIMP side, from MarketPlace side, and see how it should be this common access.
Indeed, this is Sergio here. I don't know whether you can hear me, but yeah, that's indeed the case. We need to face this issue in the upcoming months.
And then maybe, I do not know if it makes any sense. I think it makes sense that we wait to see and then turn back. Although VIMP will end next year, end of the next year. Maybe it's interesting, Martin, Jesper, you might know better, that we can try to, I do not know, using the translation router of VIMP, for instance, to call the translator catalog of MarketPlace, in case you have focused on translators catalog in there. Or I do not know if it's too basic or too unnecessary, but to take an account training, let's say, some training material that you have there ingested, and then we can see if you can call, as we can call in VIMP as well. You can search. I mean, instead going to a very complicated case that you run a simulation, that you run a workflow, or that you go into models, we could think about that.
Yeah, just to create a simple case where that actually accesses those marketplaces.
And that's how
that was your idea. Yeah.
Via this translator catalog, that we can call each other's translator catalog using this router, or in some training material, ingested training material in both marketplace that we can call, or more complicated, the models itself. Maybe not running the models, but anyway, I think in the use case, just in the marketplace, you have more a finite element or CFD or these models, right? These solvers, right?
Yes.
Because we also have maybe a CFD is implemented, something that we might be able to run in a workflow. Electronic models is something that's not very strong in VIMP. Or the molecular dynamics, or DPD, for instance, that I think we might see in the next webinar. I saw that Gianluca is there, right? Or maybe he left because we have a next meeting. I think he just left. Gianluca?
No, he's still there. Gianluca is still there. I see him on the list.
Yeah.
Yeah, anyway, no, this will again contain DPD. It's clear that the community is strong in DPD.
Yes, maybe that is the common aspect, instead of being complementary now, touching some model that both marketplaces are active in. And could be the DPD. I keep you informed anyway, Jasper. We've been in contact very often now, from now on, and I keep you informed about the React Pro.
Great. That could also be of interest, I think, to.
And Silver and Martin are also helping strongly, although they are not in React Pro, they are strongly helping because they're Osmo also.
Maybe if I can comment on the React Pro a bit more, Welke. We discussed this, right? So basically in React Pro we have, very concrete workflows that we would like to run, and where we would like to make to reuse the resources of the marketplace, basically. So for us, it's still a question how to start using the marketplaces, right? How to basically, so the first thing we thought that maybe we can basically use as a first step the marketplaces to store, for example, results of a workflow or load some input data from a marketplace. But I'm not entirely sure yet if that is indeed the good way to start approaching and talking to those APIs or not. Any comments there would be really useful.
Yeah, I mean, my assessment would be that when we want to look at how the APIs are compatible, we really need to look at the data that are stored on both marketplace platforms and where they are analogous. And that's not the same as looking at executions of a simulation workflow, which is much more complicated.
Right. So yeah. Do you mean, Martin, that it indeed would make sense that if we have a sort of, well, maybe so a realistic and probably slightly complicated workflow, that we would try to make the integration with the marketplaces in such a way that we start with basically trying to talk to the marketplaces to at least share data to the marketplaces, input or output data, or intermediate results. Is that something that indeed you think could be a useful first step?
I guess at the first, as the first step, we need to look at data that are available on Sondheim space, for example, and that are also available in a similar form on marketplace.
Yeah.
Yeah. So information about the translators would be a case, or similar things that are present on the data infrastructures as such, that don't require first doing a simulation, because this is much more complicated.
Yeah.
And in the next step, then we can look at actually starting simulations.
Right. Okay. Okay. That sounds good. That sort of confirms the way I was looking at this. And then, you know, if you look at it from the data perspective, you could basically see that we could, from the XPro point of view, implement maybe some simple client library that basically is able to talk to both marketplaces, right? Using their both their APIs, then you solve the problem basically at the client side in a way. But I think that could be that might be a useful start from my perspective. But I don't know if there's anyone else from the Expo who has, I don't know if this is ideas shared by the others from the Expo who are on the line, but.
Hi, Lars. I think it's really a good start, because to start with this use case, because last time we spoke mostly on the simulations, but I think we can even simplify the problems you just mentioned. I think it will be great if you can start by such, yeah, small case, or easier, let's say, case. For me, it also makes sense. I don't know if, yeah.
Okay, so from the Expo point of view, I think we should then clearly define what is the input to our say prototype workflow. What's the output that we get? Are we able to basically, for example, store that input on both marketplaces? Can we retrieve it from there? Can we then run the simulation for the time being, you know, locally on our shared system, and can we then store the results, for example, on both marketplaces? That to me would seem a very concrete starting point. So maybe we should discuss who, yeah, maybe the next step could be that we discuss internally in Expo, yeah, who can be the contact persons, right? And then try to sort this out with the with contact persons on the VIMMP and MarketPlace. That would be great for us.
Good. Gabriele, what do you think? Before everyone leaves, should we conclude?
Oh yeah, sorry. Yeah, in case there are no further questions or issues for discussion, then I propose, yeah, to put an end to today's meeting. Of course, if everyone else agrees. In that case, yeah, thank you everyone for participating, and thank you again to the speakers from SINTEF and STFC. We had over 50 participants, so it was good success overall. So in that case, thank you everyone, and I propose to put an end to this meeting. Okay, goodbye everyone.
Yeah,
Thank
you.
you.
Thank you. Thank you.
Thank you very much.
Bye-bye.
Bye. Bye. Bye.
Thanks. Bye-bye.
Bye.
Bye.